Okay, let's as all good physics students know, we want to draw a problem, right? We've got a ramp, and the ramp is at 25 degrees. Hello, 3. 25 degrees. We've got a block of wood. We know that the height of this is 3.1 meters, and it's going to slide down. It's a hill, and the question is, how far, we'll call this delta x, is um, the sledder going to sled? All right, and actually the box is at the top of the hill. So here's something, if you recall, in a ramp, that this triangle is equivalent to this triangle right here, where this right here is the weight of the object, okay? And then this right here is the normal force, okay? So the acceleration when you are on a non-level surface, if you recall, acceleration is just g sine theta, because the g is just g sine theta will be your acceleration. That m, if you will, would cancel out. And so in this case, g is 9.8, right? 9.8 times the sine of 25 degrees. And I got, what did I get? I got 4.14 meters per second squared. So that is the acceleration, and actually that's going to be the acceleration of this object. But the question is, how fast? What I really want to know is I want to find v1, and it's eventually going to stop. v2, of course, will be 0. But I need to find what the v1 is, and so I have to use a kinematics equation, all right, where I can say v2 squared equals v1 squared plus 2a times delta x. So how far, so I know v2, I want to find this. I want to find how fast is he going right when he gets here, which actually, this v2 becomes this v1, all right? So v1 is 0 squared plus 2 times 4.14. Oh wait, I need to figure out how long is this hill. Now I know that this height of the hill is 3 meters, but that doesn't tell me, I need to know what the hypotenuse of this triangle is, right? And so let's do that, a little math here. We can say that's opposite over height, so that's sine. Sine of 25 equals 3.1 over x of the hill, right? And so if I do the math, it's just 3.1 divided by sine 25. I get the hill length to be, what do I get the hill length to be? 7.3 meters. So x of the hill is 7.3 meters. So that number goes here. And then when I do the math, by the way, when I get this, I'm going to have to take the square root of it because this is v2 squared. I get v2 to be 7.8 meters per second, which is the speed at the bottom of the hill. So it started out at 0, and now it goes to 7.8. Now this is the new v1, because now there's no more acceleration, because now it's on a flat, frictionful thing. Okay, now there's friction going on. The friction is going to slow it down. And so then what I do, of course, is that if you've got the sled, right, I'll draw a picture here. If this is my free body diagram, the sled has a weight, and it's got a normal force, and there's a force of friction pushing it down, and then the force forward, which is slowing it, the force of the applied force. Now, so we've got these forces, but the force of the friction will be equal to the weight. And again, they did not give us the mass of the sled. If they don't do that, make up a number. And so I did the problem. I said, let's call it 50 kilograms times 9.8. Actually, I didn't do that right. I'm going to say the weight is 50 times 9.8, and I got 490. Now, it turns out that the weight's going to cancel out, or the mass is going to cancel out, But then what I can do, because that's the normal force, right? And if you recall, the force of friction is equal to mu times the normal force. But they gave us the mu is 0.08, so that's 0.08 times 490. And that gave me 39.2. But then I want to find, you see, I want to find the acceleration. What is the acceleration, the negative acceleration? I can then say, I'll put it over here, 39.2 newtons, this is F, equals M, which is 50, right, because we just, times A, and I get A to be equal to 0.784 meters per second squared. So if I know that this is 7.8 meters per second, this is 0, and the A is actually negative 0.784, the question is, how far is the track? How far is delta x? And then you'll do V2 squared equals V1 squared plus 2A delta x. V2 is 0, so 0 squared equals 7.8 squared plus 2 times negative 0.784 delta x. Solve for x, and you get x to be 39.